welcome to This Explainer. Today, we're diving into one of the absolute biggest puzzles of our time. I mean, think about it. How on earth are we going to charge millions upon millions of electric vehicles over the next decade without completely melting down our power grids? It's a massive challenge, right? But here's the cool part. Today, we're going to see how cutting-edge artificial intelligence, the digital brains up in the cloud, is teaming up with some seriously innovative mobile hardware, the physical brawn on the streets, to completely solve this thing. Let's get right into it. Okay, real quick, here's our roadmap for today. We'll look at the core EV infrastructure challenge, introduce our new AI conductor, see how we balance the ecosystem, check out that AI in action, take charging on the road, and wrap up with the future of mobility. Section 1, the EV infrastructure challenge and the $25.5 billion vehicle-to-grid market. We are staring down an impending grid crisis thanks to the massive boom in electric vehicles, which brings us to the ultimate question driving this huge $25.5 billion market. How exactly do we power the EV revolution without crashing the grid? Just imagine this. Millions of commuters get home at 6 p.m., and boom, they all plug in their cars at the exact same second. If we don't manage that properly, that synchronized spike in demand will literally overload transformers and trigger massive blackouts. It's a coordination problem on a scale we've just never had to deal with before. And man, it gets wildly complex when you look under the hood. We aren't just dealing with when people plug in. To safely coordinate all this charging, the system actually has to look at 20 distinct contextual features. Think about weather patterns and solar irradiance. If a cloud suddenly passes over a solar farm, renewable power drops instantly. Then add in real-time traffic congestion that delays when cars actually arrive, minute-by-minute grid load fluctuations, and dynamic electricity pricing that's constantly shifting. It is a staggering amount of data. Try running that through a rigid, old-school grid system, and it would just instantly break. Section 2. Enter the AI conductor, or context-aware multi-agent coordination. To handle all this chaos, researchers built an incredible framework using an application called Smart to Charge. You can think of it as a hyper-intelligent traffic conductor for the entire energy grid. At the core of this is what's called a multi-agent system. Simply put, it's a computerized network of autonomous, intelligent digital agents. So instead of one giant, clunky central computer trying to micromanage everything, you have these independent agents representing the cars, the chargers, the grid itself, constantly talking and negotiating with each other. They figure out how to allocate resources on the fly, collaborating to solve problems that are just way too massive for a single system. The brains behind this operation is the KMAC Draw framework. It uses this brilliant graph neural network to literally read the room. It constantly processes those 20 contextual features we just talked about, the weather, the traffic, the spatial topology, the pricing, and uses smart attention mechanisms to figure out what's most important in that exact millisecond. Then, it tells each station and vehicle exactly what to do to keep everything humming along perfectly. Moving on to Section 3, balancing the ecosystem and the 5 key stakeholders. Now, for this AI conductor to actually work, it can't just prioritize the power company. It has to perform a massive juggling act to balance the competing and sometimes totally opposite interests of everyone in the ecosystem. So, the algorithm perfectly weights 5 key groups. It gives EV users the top spot at 25%. Because hey, we all want fast, cheap charging, right? But then it allocates 20% to grid operators to prevent those blackouts, 20% to station operators who still need to turn a profit, 20% to fleet operators who have to keep their delivery vans routed efficiently, and finally 15% to environmental factors to maximize green energy use. The AI basically forces all these competing priorities to compromise and play nice. Section 4, AI coordination in action. Let's look at some real-world results. You know, it's one thing to have a slick, theoretical AI model that looks great on a whiteboard, but the hard data here is just phenomenal. In practice, this system hits a massive 92% coordination success rate, completely blowing older baseline algorithms out of the water. On top of that, it achieves a 15% improvement in energy efficiency. So basically, the AI is incredibly good at gobbling up power when it's cheap and green, and totally backing off when the grid starts getting stressed. But let's bring this down to earth. What does all this fancy optimization actually mean for you? Well, it translates directly to a 10% cost reduction. By smartly navigating those tricky time-of-use tariffs and dynamic pricing without you having to lift a single finger, the AI literally shaves 10% right off your charging bill. That is a real game changer. And just to prove this isn't some tiny lab experiment, the researchers actually validated these deep reinforcement learning models using over 441,000 real-world charging transactions. They collected this data across 13 different stations over 2 full years. Even with wild seasonal changes and weird grid anomalies, the system maintained 94% reliability rate. The science here is absolutely solid. Section 5, Taking Charging on the Road. The physical hardware solution. All right, so we've got the digital cloud sorted out with AI. Now let's pivot to the physical streets. Because to scale electric fleets, we need hardware that can jump in where the traditional grid just can't reach fast enough. Think about standard, static grid dependency. Building stationary chargers means tearing up concrete, huge infrastructure costs, and you're totally limited by the local grid capacity in that one specific spot. But contrast that with off-grid mobile flexibility. What if the charger just drives right up to the vehicle? Boom, zero strain on the local grid, and you get modular, on-demand power exactly where you need it. To really ground this hardware side of things, take a look at this quote from Stephen Kelly, the CEO of L-Charge. They're pioneering some amazing off-grid EV charging solutions. Talking about their new mobile charging and roadside assistance vehicle, he says, "It's a service truck first, with high-power EV charging integrated in a way that doesn't compromise space, safety, or productivity." And the engineering making this happen is so clever. Usually a mobile charger is just a giant, heavy battery taking up the whole truck bed, and eventually that truck has to go plug itself in anyway. L-Charge completely flipped the script. They take a standard Ford truck with a 7.3-liter gas engine. When that engine runs, it engages a power takeoff, or PTO system. That mechanical energy is converted straight into electricity, powering the world's smallest 60-kilowatt DC fast charger for up to 15 continuous hours. The best part? The truck still keeps all its bed space for fleet servicing tools, and there's no need for massive, heavy onboard batteries. Finally, Section 6, the future of mobility, where intelligence meets flexibility. Bringing it all together, we can really see how these software and hardware threads weave perfectly into the complete picture of our electric future. It's intelligence finally meeting physical flexibility. So what's the big takeaway from this explainer? Well, up in the cloud, AI systems like Smart2Charge act as our traffic conductor, processing billions of data points to balance everyone's needs and prevent grid blackouts. Meanwhile, down on the ground, flexible off-grid solutions like L-Charge's trucks fill in those physical coverage gaps so we don't have to wait years for grid upgrades. Together, they allow you to save 10% on costs and drastically slash our overall grid dependency through smart renewable integration. It is just an incredible two-pronged approach. We're tackling the biggest bottleneck of the 21st century by making our digital systems smarter and our physical infrastructure more adaptable than ever before. So I'll leave you with this. As AI learns to perfectly conduct the flow of power and off-grid trucks bring the fast charger directly to your bumper, are you ready for a hyper-intelligent modular transportation future? Thanks for hanging out with me for this explainer, and I'll catch you next time.